Good afternoon, friends, and good morning to some of you. Thanks for taking interest in the RAMS, System Engineering, and System Assurance courses. I am Dr. Mukul Verma. I will be the tutor for RAM part of the courses, that is, reliability, availability, and maintainability. I have over 30 years of experience in application of RAMS methods to various systems. I started my career as a railway signal engineer, where I developed electronic interlocking system for railway signaling. I was awarded PhD degree from Indian Institute of Technology, Delhi on this project. Thereafter, I was involved in RAMS assurance and safety certification of signaling systems. I am a chartered engineer of Engineering Council UK and fellow of IRAC, IET, and IETE. Coming to the courses, you may ask, why should I attend the RAMS courses when I have got an expert on RAMS in my team? Please remember, the RAMS expert in your team is there only to guide you to achieve the required level of reliability and safety in your outputs. Finally, you have to make sure that required level of reliability and safety has indeed been achieved in your outputs, whether you are a design engineer, installation engineer, or O&M engineer. The practices and regulatory requirements of the industry are changing with time. Therefore, it is important for the professionals to keep abreast of the contemporary practices and regulatory requirements of the industry. With this in mind, three of us who are well qualified in this area and who have got international experience in application of RAMS in various projects have come together to offer a course under the aegis of globally recognized consultancy firm in this area, that is Intellex Consultancy Services UK. About the faculty, my colleague Mr. Rishi Marathu, who is a postgraduate in risk and reliability and has got 20 years of experience in application of RAMS in various projects in UK, Canada, Doha, and Dubai, will be taking up the system engineering and system assurance part of the courses. My colleague Miss Madeline Hoskins will take the safety engineering. She has got more than 30 years of experience in application of RAMS in railway systems. She is a chartered engineer of Engineering Council UK, and I will be the tutor for RAM part, as I said earlier. Coming to the courses, mode of the course delivery will be online. It will be through animated PowerPoint slides with recorded speeches, handouts, Skype interaction for discussions and workshops, email communication for clarification of any issue, online tests, and award of certificate on qualification of the tests. We are also in discussion with University of Birmingham for accreditation of our courses. The courses are, the first course is appreciation course on RAMS, system engineering and system assurance. This is for 16 hours and it is meant for senior managers and project engineers. If the senior managers and project engineers appreciate the requirement of RAMS, they will be able to motivate their discipline engineers and O&M engineers to apply these techniques to their job. This course provides an overview of RAMS, system engineering, and system assurance. Next, we have got 4 module level courses which provide detailed knowledge of the topics in these modules. These are designed for competency development in a particular discipline. On completion of these courses, a certificate of continued professional development, that is CPD, will be awarded. The modules are system engineering module of 12-hour duration, RAM engineering module of 17 hours duration, safety engineering module of 18 hours duration, and system assurance module of 9-hour duration. In addition to these, we have got 3 certificate courses with varying level of depth in the subject. The certificate courses are the target audience for the certificate courses are discipline engineers, operation and maintenance engineers, and RAMS and system engineers. The courses in increasing level of details are: the course is certificate course on RAMS for 40 hours. This course provides an in-depth knowledge in the area of reliability, availability, maintainability, and safety. Next course is certificate course on RAMS, system engineering, and system assurance. This is of 56-hour duration. This includes all the topics covered in the certificate course on RAMS, and in addition it provides detailed knowledge in system engineering and system assurance. A case study on application of the methods and tools learned during the courses will be helpful for the participants to apply these techniques in their job. We have got an advanced level certificate course on RAMS, system engineering, and assurance of 96 hours duration. This will include all the topics of the certificate level course, which is for 56 hours. And in addition, this will include 40 hours live session dedicated to the case study on applying the methods and techniques to a real life project. All these courses which we have discussed has got a RAM module. I am the tutor for RAM module, and I am going to give you in brief what will be included in the RAM module. The first chapter is mathematical foundation. This includes probability theory, Boolean algebra, and matrix algebra. All the RAMS parameters are probabilistic in nature. This is because we cannot predict with certainty when a component will fail or for how much duration a subsystem or system will work. We can only express these things in terms of probability, that this is the probability that this system will keep on working for, say, 1 year without any failure, or this is the probability that this component will fail during a given time t. Therefore, a sound knowledge of probability theory is required to deal with the RAMS parameters. We will go into the theorems of probability, conditional probability, independent and dependent events, probability of several events occurring simultaneously. Now, this is an important topic because a system consists of a number of subsystems, and we are interested in finding out whether how many components will fail simultaneously and so on. We will also touch upon Venn diagram to for calculation of probability. Then we will go for detailed discussion on Boolean algebra. Now remember, our all our events, many of our events are binary in nature. For example, a component is working or not working. A system has failed or is working. To deal with these binary events, we need knowledge of Boolean algebra. We will discuss Boolean algebra, which will be required in later for several mathematical tools like fault tree analysis, event tree analysis, etc. There are many state dependent systems. Analysis of these systems requires Markov chain analysis, which depends on matrix algebra. We will go into fundamentals of matrix algebra in this chapter. Next is the RAM parameters. All of us desire to have a very reliable or extremely safe system. But these terms, very reliable and extremely safe, are subjective and ambiguous. This may mean different things for different stakeholders. Therefore, it is essential to define certain RAM parameters, to represent them mathematically, and to be able to do mathematical analysis of these parameters. In this chapter, we will learn about the RAM parameters, like in addition to RAM, we have MTTF, MTBF, MTTR, failure rates, etc. We will also see their mathematical analysis and interrelationship between these parameters. There are various misnomers in RAM parameters. At various places, I have heard people saying reliability of this equipment is, say, 99.9%. In this chapter, you will learn that this is incorrect way of expressing the reliability. There is also a misnomer that a component is very likely to survive till its MTBF. In this course, you will learn mathematically, you will learn how to prove mathematically that the probability of survival of a component to its MTBF is only 37%. Formal knowledge of RAMS is like a language which you need to know for effective communication with the stakeholders. If you know about these parameters in depth, you will be able to effectively contribute in the meetings and workshops. The next chapter is on RAM modeling. You will be required to calculate the system level RAM parameters from that of the subsystems or components. This is required because you have to demonstrate that a given level of reliability and safety has been achieved for the overall system. Now, how to calculate the RAM parameters of the overall system from that of the components? We have got several techniques. We will discuss reliability block diagram, where each component or subsystem is represented by blocks, and then this RBD reliability block diagram is solved, is reduced by series parallel methods, decomposition methods, enumeration methods, and finally the reliability or availability of the system is calculated from that of the components. We will also learn about fault tree analysis. There are some state dependent systems say repairable systems which are difficult to analyze by RBD or fault tree analysis. You will learn about Markov chain analysis for dealing with such systems. At several points, you will realize that it is not possible to achieve the required reliability and safety of a system by simple design techniques. In these cases, a special design techniques like fault tolerance design technique has to be employed. You will learn what are the systematic and random faults, what is hardware redundancy, various configurations of hardware redundancy and software redundancy to achieve fault tolerance. If you are dealing with safety systems, then there is a requirement that a system which has got safety function at SIL 4 should never fail and give unsafe output by failure of a single component. Therefore, you have to apply redundancy techniques. You will learn about these techniques in this chapter. Then we will deal with software reliability. The failure modes of software is different from that of hardware. Hardware deteriorates with time, but software doesn't. Therefore, software doesn't have random failures. Software will have only systematic failures. But you will also see that the systematic failures of a software manifests into random failure of the system because failure of the software depends on the input data. In this chapter, you will learn more about software faults and software reliability. At many for design of a system, you may be given a system level reliability or safety target, and as a system integrator, you must assign proper safety and reliability target to the subsystems or components so that when they are integrated, they give you they provide the same required level of safety and reliability. This is called apportionment. You will learn the RAM apportionment technique by which you can assign reliability target to the components based on the reliability target for the system. You before handing out the reliability or RAM target to the subsystems, you would like to make sure that on integration they will provide the reliability and safety requirement as required for the system, and you should be able to demonstrate this. We will learn about Monte Carlo technique for simulation, which helps in this process. Then in final RAM analysis, you need to, this is when you have designed the complete project, you need to prove that the required RAM target has indeed been achieved. In this chapter, you will learn more about final RAM analysis. RAM deliverables is is an important part of any project. In this chapter, you will learn what are the contents of various documents, how to prepare the documents, what are the requirements for review of these documents, and how to reconcile these with other stakeholders. Well, with this, I end the discussion on RAM module. Now we come to system engineering module, which will be taken up by my colleague, Mr. Rishi Marathu. In system engineering, he will be dealing with mainly dealing with outline of system engineering, system life cycle, system engineering application to railways, system engineering disciplines such as requirement management, interface management, verification validation, etc., and whole life cost. Another module taken up by Mr. Rishi Marathu is system assurance, which consists of two parts. One is system assurance process and system assurance attitude. Under system assurance, he will be dealing with risk-based assurance, self-assurance regime, progressive assurance, system assurance planning, gate reviews, assurance management, and audits, etc. In system assurance attitude module, he will be taking up project stage based evidence maturity, risk management through assurance, commitment to reputation, success by collaboration and assurance, and process of handover to O&M, etc. My colleague Miss Madeline Hoskins will be taking up the safety engineering, under which she will discuss about hazard analysis and risk acceptance, safety integrity levels. This is an important part, how to assign a safety integrity level to a system and how to demonstrate that this level has been achieved. She will deal with Ssenior standards, the main standards related to railways, which are EN 50126, 50129, and 50128. She will also discuss safety analysis tools like fault tree analysis, FMECA, event tree analysis, etc. The next topic is common safety methods, safety case, engaging and independent safety assessor, and production and review of safety deliverables. Thank you for your attention. I have completed my module. If you have any question, kindly type it out on the chat window. I will be glad to respond to them. Meanwhile, the program of the forthcoming webinars are given on your screen. These webinars, which are due on 17th July, 24th July, and 31st July, will be by invitation. Only for those of you who have registered for the course, you will receive invitation for these webinars, which will give some more details about the course. Thank you very much for your attention. Hello, there is a question on how do you cover RAMS tools like isograph, item toolkit, etc. No, we will not be covering these tools in this course. A few people have also asked, uh, what about the accreditation of the courses? Well, accreditation, we are already in discussion with Birmingham University, and we are hopeful to get accreditation of our courses. There are some questions on maximum time allowed for completing the course. Well, the course maximum time will depend on the uh, courses. Like for advanced course, it will be for 4 or 5 months, within which you have to complete the 56-hour module, and then you are eligible for the advanced case study. There's some questions on number of attempts that a candidate can take on the for the tests. Yeah, for test, I think we have kept 3 attempts. You must clear the test within 3 attempts. You have gone through the courses. It will be not difficult for you to uh, clear the test in first attempt itself. But if you fail to do that, you will be given access to all the course materials. You can do revision, and then you can take next attempts. Other questions are, yeah, then some technical question like mathematical problem in online test. Well, tests will only our tests will be designed in such a way that your understanding of the course will be tested. It will not be mathematical calculations, detailed mathematical calculations. But yes, you need not remember the formula. But yes, you should know how to apply the formula and how the concepts are cleared. There are some questions on software reliability. How do you improve software reliability? Well, under the chapter of fault tolerance, you will learn how to uh, use more than one software. By use of diverse software, you can enhance the software reliability. Any other question is there? You can type it out on the chat window. I will just address some questions which we have got by mail earlier. Uh, will there be some contact in which the issues will be cleared? Yes, you will be given a contact, a common contact on which you can send email for clearance of any issue. Okay, then there is some question on thanks for the same. Okay, there is a comment that you touched upon more than one equipment failure at a time. That means simultaneous failure. Yes, actually, particularly for safety systems, uh, if first failure is not detected, that means you don't have procedures like self check, other things to detect the first failure in time, then the second failure should also be considered. This is as per the Senelec standard. And what should be the time within the first failure is to be detected? That depends on the safety integrity level. For SIL 4, it may be a few milliseconds, or I mean, this has to be calculated so that the SIL is achieved. There is another question. As you know, that most of the railway signaling design, we are designing one failure occurrence at any point of time. Is it necessary to make account for simultaneous failure? Well, I said that normally in signaling system, we consider one failure at a time. But if the detection and correction time, for example, suppose one IC chip has burnt off, if you can detect and take the system to safe side within a given time. Now, this given time delta t has to be decided by calculation of probability. If you are not able to do that, then you must consider multiple failures as per the Senelec. Uh, Let me see, some other more questions have come. Will you provide study material? Yes, you will have access to the online uh, PPT slides and recorded speeches. That is one part. Also, you will be able to see the notes by the side of it, and you will have hard copy of, you will be provided hard copy of the in the form of class notes. So this will be your takeaway. For how much time I can access the course? Well, it depends on the course. As I said, for the advanced course, it will be 4 to 5 months. After that, the access will be denied. Will there be any special offer if we complete one module course and opt for advanced course? I don't think there is any special offer is there, but we can take up the items as per the situation. Okay, I think that we don't have any more questions. In that case, I will say thank you for listening to the description of the courses, and thanks for the questions and for attention. Thank you. If you have any further question, just you go to the site. There is a mail ID given. Kindly send your questions or any clarifications on the site. Thank you.